with chapter 1. We're going to cover section 6A. We're actually going to split it into 3 days. The beginning parts of the notes today, up to probably example, I believe it's 9, it's a review of what we did already in the prerequisite chapter. It's not going to be until I get to example 10 where it's going to be something new. And it's going to be a technique called U-Substitution. So it'll be a little bit more challenging, but it's going to make the questions a little bit easier to factor. So let's go ahead and see how we can solve polynomials. So in the notes today, when we're solving polynomials, all of the examples today can either be factored, whether it's factor by grouping, whether it's just factoring a trinomial. But honestly, when you're solving polynomials, the fastest way to solve a quadratic is factoring. You can do quadratic formula technically. You can do completing the square. Sometimes the problems are better set up to do square root method. But honestly, once you get the hang of factoring, it's usually the fastest way. What we're going to be doing is we're going to be graphing polynomials, and we're going to need to find the intercepts. And when we factor a polynomial and then solve it, the answers we're getting are the x-intercepts. So this is all leading us now into graphing polynomials. So always, whenever you're factoring, you should always look for a GCF first. And then from there, this third bullet point is what is going to start with example number 9. And it says, if the variable on the first term is the square of the middle term, you can use substitution to simplify the polynomial. And this is called, I use the letter U. Some books may use a different letter, but it's called U-Substitution. And this is what is the new information. Again, the first 9 examples should be a review. So let's try them. So the first one, it has 3x to the 4th equals 48x squared. So the first thing I want to do whenever I'm solving is I need to set it equal to 0. So I'm going to go ahead and move my 48 over. So I'm going to subtract it, 48x squared from both sides. And I get 3x to the 4th minus 48x squared equals 0. I'm going to look for a GCF. My GCF is 3x squared. So I'm going to divide. And now I need to keep going. I can still factor it, because after I divided, this is the difference of 2 squares. So I'm going to keep going. Don't forget about your GCF. Keep bringing it down. This will factor into x minus 4, x plus 4. And now that it's fully factored, I need to take everything, including the GCF, and set them equal to 0. And now I'm going to solve. And I'm going to divide by 3. X squared equals 0. I'd be using the square root method here, and I should be getting plus and minus, but there isn't a positive and negative 0. So this answer is just 0. Going to add the 4. X equals positive 4. Subtract the 4. X equals negative 4. So I actually have 3 answers here. Now, a clue for how many solutions you're looking for is always going to be the largest exponent. Notice my largest exponent was a 4. So I should be getting 4 answers. Technically, the first one, the x equals 0, there's 2 answers there. It's x equals 0 and x equals 0, but I only list it 1 time. If it were a number other than 0, it would have been plus minus, and that's how I would have gotten 4. When we go to graph these, the place where my graph is touching the x-axis at 0, what we're going to learn is it's a bounce. It's going to touch and it's going to turn away. All the other ones, when the solution occurs only one time, it's actually going to cross through the x-axis. So all of these numbers that I just circled in red, these are all my x-intercepts. This is what we're going to be doing when we're graphing. Let's try the next one. Yes?
Could you also write as x plus or minus?
Absolutely. So you could have also, now in what, that's a good question. So in WebAssign tonight, it's going to tell you to separate your answers with commas. On my test, you can write it like this, or you can say what Nicholas just said, and you could have also put it as x equals plus and minus 4. Absolutely, and the x equals 0. So in my test and quiz, you can use the shortcut. In WebAssign tonight, you're going to separate them with commas. All right, next. Again, it's already set equal to 0. Always, always, always look for a GCF first. So I'm going to divide both of these by 3x squared again. If it helps you to see how you're dividing, but don't forget about that GCF because that's one of my answers. So after I divide here, I get 3x squared minus 4 equals 0. This is not the difference of two squares, so I can't factor it any further. So I'm just going to use my square root method. So I'm going to take each of the factors, set them equal to 0. So this factor gets set equal to 0. And then what was in the parentheses, also set that one equal to 0. And again, you're going to solve this one. X squared equals 0. I'm really square rooting it. So x is equal to 0. Again, there's no such thing as a plus minus 0. And then add 4. 3x squared equals 4. Divide by 3. And x squared is equal to 4 over 3. I need to square root it. So now I get x is equal to plus and minus the square root of 4 over the square root of 3. I got to rationalize that. So let me move it up here. So I pulled it apart just so you can see it a little bit better. Now the square root of 4 is actually 2, so I can pull that out. But now I need to, and this is plus minus, remember, I got to rationalize. So I'm going to multiply it by root 3. So my final answer is plus or minus 2 square root 3 over 3. And then don't forget about your other answer, which was x equals 0. So again, 4 answers I was looking for. Remember, the 0 counts for 2 of them. And then you've got the positive 2 root 3 over 3 and the negative 2 root 3 over 3. Now, whenever you're taking an SAT or a PSAT, what we're doing here, you might see the instructions and they may say solve the polynomial. They might say find the x-intercepts of the polynomial. They might say find the roots of the polynomial, or they might say find the zeros of the polynomial. This same question could be asked all those different ways. So just be aware of the terminology. Let's try number 3. This one I'm going to factor by grouping. It's a 4-term polynomial. Always, always, always look for a GCF first. And then as soon as you see 4 terms, think grouping. So I'm going to make 2 groups. I'm going to have x cubed minus 3x squared as my first group. And then my second group, 3x minus 9. And then this is all equal to 0. So GCF of blue is x squared. And again, this is all still review of what we've already done. So plus 3. Remember when you factor by grouping, what you end up getting after you divide must be the same. And then you write it once. And then also write the 2 GCFs together. Set each of your factors equal to 0. So x squared plus 3 equals 0. And x minus 3 equals 0. Move the 3. X squared equals negative 3. I need to square root both sides. So x is equal to plus and minus I square root 3. That's the first one. And then this one over here, add 3, and x equals 3. So we are still looking for imaginary solutions. We would not say no solution here. We will not graph imaginaries. You'll do that in a later course. But if it asks you to list the x-intercepts, you would still list the imaginaries. So again, this has the biggest exponent was a 3. So notice I've got 3 answers. I've got positive I root 3, negative I root 3, and then I've got the 3. So those are my 3 solutions, which are also my 3 x-intercepts, my 3 roots. All of these terms mean the same thing. Let's try example 4, another 4-term polynomial. Notice there's no GCF that I can pull out. So let me make my 2 groups. X cubed, 5x squared, it's my first group. And then negative 2x plus 10, that'll be my second group. And now I need to look for a GCF out of my first group. It's going to be x squared, divide. GCF of my second one, in order to make it look the same, if I just pull out a positive 2, it's not going to look the same. So I'm going to pull out a negative 2 GCF. And now what I have in the parentheses is the same. So write that one once and then put the 2 GCFs together. The order that you're writing this down doesn't matter. I now need to set each of my factors equal to 0. I'm going to add 2. X squared equals 2. I use my square root method. So x is equal to plus and minus the square root of 2. Over here, I'll add 5. X is equal to 5. So these are my 3 answers. Again, on WebAssign, you'll have to split them apart. So negative root 2, positive root 2, and then 5 are the 3 solutions, which are also my x-intercepts.
You have the last one?
Yes. All right, everybody good so far? All right. So for number 8, let me just rewrite it over here. 9x to the 4th minus 37x squared plus 4 equals 0. I'm going to just go ahead and guess and test on this one. So factors of 9 are going to be 9 and 1. Factors of 4, I'm going to use 1 and 4 as well. And then it's a positive 4, but the sign in the middle is negative. And then if I'm going to guess and test, remember you got to do outside and inside. This will give you 36x squared. This gives you 1x squared, and they're both negative. And when you add them, you do get the negative 37. So for this one, it was probably faster to guess and test. Again, if you're good at this, and once we do enough of these, you're probably going to get really good at guessing and testing. So again, remember, this is all set equal to 0. So now I can keep going here, or I could use my square root method. Just remember, you're going to get plus and minus. But here, this will be, if I factor it, 3x minus 1, 3x plus 1, x minus 2, x plus 2. Set each one equal to 0. X plus 2. So add the 1. 3x equals 1. Divide by 3. So my first answer is x equals 1/3. This one will give me the negative 1/3. This one I'm going to add 2. X equals 2. Subtract 2 on this one. And x equals negative 2. So I have 4 answers, positive and negative 1/3, and then positive and negative 2. Okay, so when you watch this slide, it may be backwards. I actually, the audio is going to have me solving number 8 first, and then now I'm going to finish solving the rest. So number 5, same thing. We're going to factor out a GCF first. GCF is 3x. So don't forget about that GCF. So after I divide, I get 2x squared minus 9x minus 18 equals 0. I now can factor the trinomial. I'll go ahead and do factor by grouping. So factors of 2 times negative 18, and it's going to be a negative 36x squared. So it'll be negative 36 times positive 1, 2 times negative 18, 3 times negative 12. That's the magic combination. So let's go ahead and put this in here. Rewrite the first term. Put in the 2 factors you just found. Make your 2 groups. Pull out the GCF of each. Now, don't forget about this original GCF because that's one of my factors. So then a GCF here is x, so 2x plus 3. GCF of blue will be negative 6. And now set it equal to 0, each one of the factors, and I'm going to keep solving it over here to the side. So take the 2 things here, the 2 GCFs you divided by. They go in a parenthesis together, as well as what you got when you divided. Now set each one equal to 0. So the GCF, don't forget about it, as well as this guy. So divide by 3, x equals 0, x equals 6, subtract 3, divide by 2, and x equals negative 3 over 2. So again, here are your 3 answers. So WebAssign will ask you to enter them with commas, negative 3 over 2, comma 0, comma 6. Number 6 sort of looks like a quadratic. I'm going to guess and test on this one. Factors of x to the 4th are going to be x squared times x squared. Factors of 2 are going to be 2 and 1. And the signs have to be the same because it's positive, and the signs that they'll both have is the sign of the middle. Set each one. Actually, I can factor this one. This one I can't factor, so just rewrite it. Now set each of the factors equal to 0. And solve for x. So subtract 1. First solution is negative 1. Next one is positive 1. Here I'll add 2. Use my square root method. So x is equal to plus and minus root 2. So I'm looking for 4 answers because it was raised to the 4th power. On WebAssign, you're going to have to enter them all separately. For my test, you could actually tell me that the answers are plus and minus 1 and plus and minus root 2. I'm okay with that. And then now number 7. Again, I'm going to do it the same way. Guess and test. X squared, factors of 12, that will give me 7, are going to be 3 and 4. This one can be factored. This one cannot. Set each of the factors equal to 0. Add 3. X squared equals 3. Use your square root method. So x is equal to plus and minus the square root of 3. Here I'm going to subtract 2. Another answer is negative 2. And then also positive 2. Notice it was to the 4th power, and I do have 4 solutions. And then at the beginning of the slide, I actually did number 8 first. The slide was a little backwards. So that is it. All right, number 9, still a review from chapter P. It's just a rational equation. I'm going to get rid of the fraction. My LCD is going to be x squared. So let me just rewrite my problem underneath here. So I'm going to put 1 over 1, 3 over x, negative 2 over x squared. So I'm going to multiply my entire equation by the common denominator, which is x squared. So remember, we're going to distribute it. So x squared, nothing cancel, so I'm just left with x squared. We'll do it here in black so it shows up better. Then I'm going to distribute it to the middle one. The x will cancel, so now this just gives me a 3x. And then when I distribute it to the last term, the x squared cancels, and I'm left with equals 2, negative 2. I need to put this in standard form so I can factor it. So I'm going to add the 2. X squared plus 3x plus 2 equals 0. Factors of 2 that give me 3 are going to be 2 and 1. Set each factor equal to 0. Subtract the 1. X equals negative 1. And x equals negative 2. 2 solutions. All right, here we go. Now, the first time I'm going to do it is I'm going to do it, we did enough of these. I'm going to just jump. Now, actually, let me show you both ways. Now, whenever it's something like this that sort of looks like it's quadratic, you can still factor this the normal way. But I want to show you first the U-substitution by doing a simple problem like this. So technically, I could solve this one this way. I could factors of x to the 4th are going to be x squared and x squared. Factors of 2 are 2 and 1. This time, though, again, positive, so this number's positive, so the sign in the middle is negative, so both of my factors are negative. This one cannot be factored anymore, so just set it equal to 0. This one I can factor into x plus 1, x minus 1. You could also just set it equal to 0. Just remember, you're going to get a plus minus. Add the 2. X squared equals 2. Square root it. X equals plus and minus square root 2. Over here, set each of these equal to 0. So nothing new here. This is the same thing that I've been doing. I'm going to do the same problem, but I'm going to introduce U-substitution. So notice it was x to the 4th. So I need 4 answers. I got 4 answers. Now, let me introduce U-substitution. Now, if you remember that third bullet point back on that first slide, stated that if the first term is the same as the square of the middle, then we can use this substitution technique. Let me show you how we're going to do it. Let me just rewrite the problem. So I have x to the 4th minus 3x squared plus 2 equals 0. So then now what I'm going to do is I'm going to let u equal this part of the middle term. So then what I'm really having here is that u squared, so if u is equal to x squared, and then I come in here and square the u, that's how u squared is really x to the 4th. So now let's go ahead and replace wherever I see this. So I'm going to replace the x to the 4th with a u squared. I'm replacing this x squared with a u. And now I have a much simpler quadratic equation that I can factor. So u minus 1, u minus 2. Going to solve for u. Going to add 1. U equals 1. add 2, u equals 2. Now, the question's not going to say find the value of u, it's going to say solve for x. So now what I have to do is go back to see what I set u equal to, and I got to substitute that in. So really what I'm going to get here now is x squared is equal to 1, and x squared is equal to 2. I'm going to use my square root method, and I get x is equal to plus and minus 1. X is equal to plus and minus root 2. Same answers I got when I did it, factoring it up this way. Now, when it's simple like this, you can do it the other way. It's when we're going to get fractions and radicals where you're going to want to use the U-substitution. All right, so the previous question, what I forgot to do was remember whenever you have a rational equation, we have to check our answers. Both of these answers work because neither of these answers make either of the denominators a 0, so they both check. So always remember that when you have a rational equation, you have to check it. Okay, so we need to try to factor this crazy looking thing. Okay, we got rational exponents. So this is where using my U substitution is going to pay off. I am going to set U equal to this middle term. So U is going to equal x plus 1 to the 1/3 power. And then if I square both sides, so then if I take it and rewrite it again, but then I show the square that's going to come in here. So then if I just decide to show you that I'm going to square both sides, then this ends up being u squared is equal to x plus 1 to the 2/3 power, which is what I have right here. So I'm going to replace my first term with u squared. I'm going to replace my middle term with u, and then just rewrite the third term and set it equal to 0. I have a nice, easy quadratic equation that I can factor. This will factor into, the signs have to be different, u minus 2 and u plus 1. Because negative 2 times positive 1 is negative 2. And then when I add them, I get negative 1 in the middle. To know when you can actually use the U substitution, it's when that middle term is going to be when you can square it and make it the first term. And again, it's going to take practice. Yes?
So would substitution be easier or harder than the other methods?
So when you have something like this, you can't use the other methods. You have to use the U substitution. So whenever you have binomials raised to a rational exponent, you're going to want to use U substitution. Or whenever you have a radical in your quadratic, you're going to want to, or a fraction, and it's asking you to factor it, you're going to want to use the U substitution. All right, so now I need to solve for u, but then I need to go back and substitute it back in. So u minus 2 equals 0, u plus 1 equals 0, add 2, u equals positive 2, u equals negative 1, and now what I set u equal to at the beginning, I need to get and put it in here now. So u is equal to x plus 1 to the 1/3 power, and I set that equal to 2, and I also set it equal to negative 1. Now, remember, this is really saying I'm finding the cubed root of x plus 1, but the easiest way to get rid of the fraction is to multiply by its reciprocal. So I'm going to raise both sides to the 3rd power, and that's, let me get green, I think that'll show up better. So I'm going to multiply and raise each side to the 3rd power. because 1/3 times 3, this becomes just to the first power. So then this x plus 1 comes out. But then I have to do 2 to the third, which is 8. I can solve this one, and x equals 7. I'm going to do the same thing over here. Raise both sides to the third power. X plus 1 comes out. And then -1 to the third power is just -1. I'm going to subtract 1, and x equals -1. So my two answers are 7 and -2. Because -1 plus -1 is -2. And those are my two solutions. Let's try another one with a binomial raised to a fraction. So I'm going to go ahead and notice this is the first term squared. So if I square it, so my u value is going to be 2x minus 1 to the 1/3 power. So for my first term, it's going to be u squared plus 2u. I'm not including the coefficient here in my u, so I just put it in front of the u, minus 3 equals 0. Factors of -3 that give me +2, +3, -1. Solve for u. Subtract 3. And now I got to substitute back in what I set u equal to. So 2x minus 1 raised to the 1/3 power equals -3. And write it again, but set this one equal to +1. Again, I'm going to get rid of that exponent by raising both sides to the 3rd power on both equations. So again, this cancels. So then the 2x minus 1 just comes out. -3 raised to the 3rd power is -27. I'll add 1. 2x equals -26. Divide by 2. And x equals -13. Do the same thing over here. This cancels. 2x minus 1 equals 1. Add the 1. 2x equals 1. Divide by 2. And x equals 1/2. I did it again. 1 plus 1 is 2. All right, I'm having problems adding 1 plus 1. So 2 divided by 2 is 1. So the answer here is 1. All that work and could be all messed up at the end. All right, now for the next one, our u value is going to be a fraction. I definitely don't want to have to try to factor a fraction. Last two examples. So again, we're going to set u equal to this middle term. So this thing right here. Because if you notice, the first term is this thing squared. So my u value is going to be set equal to x over x plus 1. So notice I can square the u because it's the same thing. So it'll become 6u squared plus 5u minus 6 equals 0. I can guess and test here, or I can factor by grouping. I'm going to guess and test because the factors of 6 are just 1 and 6 and 2 and 3. I'm going to try 2 and 3. So 3 3u and 2u. And then for the other 6, I'm going to do 2 and 3 as well. And here it would just be a matter of guessing and testing and seeing if they're in the right spot. Once I FOIL this, it does go back to my original. You could also have done this grouping, whatever you're more comfortable doing. So set each of the factors equal to 0. Add 2. Divide by 3. So u equals 2/3. This one. Divide by 2. And u equals -3/2. Again, I don't want u, I want x. So now I got to substitute back in what I had set u equal to, which is always that middle term. So I'm going to do x over x plus 1 equals 2/3, and x over x plus 1 equals -3. And I'm just going to move the negative sign to one of the numbers. Now, whenever I have something that looks like this, I'm just going to solve this as a proportion. It's a lot easier. So just do the cross products. So do this times this, and this times this on both. So I get 3x is equal to, and then if I do the other product, distribute it, move the 2x over, and x equals +2. Do the same thing on this one, do cross products. 2x equals -3 times x plus 1. And it wouldn't have mattered if you move that negative sign to the bottom. You're going to get the same answer either way. And I get 5x equals -3. Divide by 5. And x equals -3/5. So my two answers are going to be +2 and -3/5. Doesn't make anything a 0. We're good. Last example's got a radical. Again, I'm going to set my middle term equal to u. So I'm going to set u equal to the square root of x. Now, let's think about this logically, how this is actually going to turn into that first term. Because remember, when you square both sides, this makes the radical disappear. So u squared is really equal to x. So what I can do here is substitute it in. So the first one is 6u squared minus 7u minus 3 equals 0. I could probably guess and test here as well. Factors of 6 are 1 and 6 or 2 and 3. And then factors of 3 are just 1 and 3. So let's guess and test. I'm going to use 2 and 3. And then factors of 3 are 1 and 3. Now signs have to be different because it's a -3. So I'm going to make this one positive, this one negative. And then FOIL it to double check it. I get -9 plus 2, and it's -7. Set each one of the factors equal to 0. Subtract 1. Divide by 3. U equals -1/3. Add 3. 2u equals 3. Divide by 2. U equals 3/2. Now, as soon as you see that you're going to be substituting, let me go ahead and put it back. So u is equal to the square root of x. And square root of x equals 3/2. I don't want to try to solve this because this would give me something negative, which isn't going to happen. So don't solve that one. But this one I can solve by squaring both sides to get rid of the radical. And I get x is equal to 9/4. And that's my only solution. And that is it for the notes on 6.1a.